Okay, where we last left off, we were just about to set up our router for port forwarding, and that's where we'll begin right now. So Alexa will be able to access your node server once we get the port forwarding set up. In your Raspberry Pi, there's some information we'll need out of your router. Um, Once it's set up the node server on the Raspberry Pi, we'll be able to send commands to your Roku. Your DSL/cable modem more than likely will be different than mine, but this should give you an idea of what has to be done. First, you'll need to log into your router, DSL/cable modem, and navigate to the page that deals with port forwarding. I think it's a good idea that you have a bookmark for your router. In my case, I just put it up on the taskbar so it's easier to get to it. Your login information as far as username may be different than mine. A lot of times if it's something that comes from cable company or DSL company, if you look on the bottom of your router, it'll give you information for logging in. It should give you your username and password. If not, you might have to refer to the manual that came with it, and if you don't have the manual with it, just look up the model of your modem up on the internet. A lot of times if you put in the model number, the manufacturer's name, and type into the search area manual, you'll find there's a lot of places you can get manuals. There's a lot of free ones out there. Okay, in the case of mine, and usually with a lot of other modems and DSL routers, you'll have at the top like modem status, a quick setup, wireless setup, and utilities, and an advanced. A lot of times advanced is where you'll find your port forwarding. So in this case, we've got port forwarding here. Okay. So you want to log in, navigate to your port forwarding. In this case, you have to enter in the IP address of your Raspberry Pi, what port you're going to use, and make sure to select TCP. Now you can select TCP and UDP. I don't think it really matters all that much, but you have to at least have TCP. And then the range of addresses that will be contacting it. In this case, I know for sure that just select all IP addresses and then apply. In this case, we've put in port forwarding for port 40,000 for our IP address of our Raspberry Pi. So yeah, first enter the IP address for your Raspberry Pi into the IP address field, and then enter the port number into the starting and ending ports. Next, select TCP for the protocol, and lastly, all IP addresses for remote port and IP, and then click apply. For our purposes, we'll be using port 40,000. Port 40,000 TCP/UDP is used for safety net for real-time industrial Ethernet protocol. If you'd like to use a different IP address, or I'm sorry, port address, you can find a list of all those ports easily just go to your search area and type in list of TCP/UDP ports, or just TCP ports, and you should be able to find a Wikipedia document giving you a list of those ports. I'll also put a copy of this link below in the description area. I'm not for sure, but it sounds like you can pick any port number that you want, just so long as TCP is listed next to it. Because there are so many ports, it'll be difficult for somebody to guess what port you're using and be able to hack into it. I highly doubt anybody's going to be interested in it, but if you want some measure of security, that's what you want to do. If your router's DSL/cable modem requires the internal port number to be filled in, use the same port number as the external port number. You'll also need the public IP address that your router is using. In this case, you'd find it next to your modem IPv4 address, and that would be located right here. I blanked it out for security reasons. So again, if your router DSL/cable modem is assigned a static IP address, you're good to go. Just write it down because we'll need it later. But if your ISP assigns a public IP address dynamically and your router reboots, you'll have to copy the new IP address down and then import that into your server.js file every time your router reboots, because it'll get a brand new IP address. And then once you add that new IP address into that file, you'll need to move that file to your compressed zip folder that you created. And then it'll have to be uploaded to the AWS configuration page, which I'll be showing you. Number 5, setting up your Raspberry Pi. To use Windows Explorer to move the Alexa/master that you downloaded to your Raspberry Pi, download it and move it to your Raspberry Pi users folder. The two files, package and server, need to be moved to your Raspberry Pi users folder. So how you accomplish this is you'll need to log in. Actually, yeah. Okay, so if you followed the whole series and done all the steps, you should see something similar to this. This is what you should see. I'm using Windows 7. So we'll go into the Home Pi. We'll also now need to navigate to where I saved the files at. So you can see here's my folder here. If we go into the Raspberry Pi, you'll see that I have not yet moved it over. So we'll go ahead and move that over just by clicking on it and then dragging it to our folder called Home Pi. And then I'll put a copy of it over here. And from here, we will want to open up the folder node server file for a computer, and then just grab these files and just drag them over to that main user. Okay, and we'll double check, make sure they're there. And there they are. Now, next we'll be installing Node. There's a couple of different ways you can do this. You can go to the Node website at node.js.org, and you can download, you'd want to click on downloads, you can download their version here, secure source code. It's in a tar.gz file, and yours is going to be in ARM. Not sure which version, but this bottom one I think covers all three. In this case, I find that really long to download. It takes a long time. So I'm going to get my version from apt-get.adifruit.com. So if you wanted to get an updated version from them, right now currently they're using, I'm not sure which version that they're using. So in this case, you'll need to log into your Raspberry Pi using PuTTY. So we'll do that. Once logged into your PuTTY, we'll just copy this command to get it. You should see something similar to this. Wait till we get another prompt. Till then, we'll go ahead and copy this. Our next step. And this doesn't take too long. It's pretty quick. Okay, we'll go ahead and paste in our our next command, and that's just by right-clicking. It'll automatically paste it in there. Of course, it's going to ask us for additional disk space. We'll put Y, and go ahead and put Y again. And we'll want to check out what version. I probably should have done that first to show you what version was installed with Stretch and what version we're putting on. For our purposes, this is going to be version 0.12.6. Okay, that's it. We'll check to see we properly installed and the right version. Now, using Windows Explorer, go to your Raspberry Pi and click the server.js file and choose Edit with Notepad. Once it's open, change your port number to the port that you're using. In this case, it's 40,000. And then change the line var Roku address equals none to var Roku address equals http:// the IP, your Roku IP, and colon 8060 and /. Okay, so we'll go ahead and change this to 40,000. And then for easy purposes, we'll just copy this. Make sure there's no extra spaces. And our Roku IP address, I believe, is 107. So we'll save this. And we can double check that. I recommend that you keep a list of your internet devices that you have a DHCP IP address. You don't want to use static, but DHCP in your router, and in that case, DHCP reservation. And we've set in there, oops, must be logged in again. Must have timed out. So we've set that DHCP reservation to enable. Automatically set DHCP reservation on DHCP IP allocation enabled. We've entered in our beginning and ending IP addresses that we've reserved just for DHCP reservation. This way you can select a MAC address of the device that you want a certain IP address to be given to every single time, and then you can also manually add the MAC address if it doesn't show up in the list, and then what IP address you'd like it to have, and then click apply. And then it'll propagate a list of those things. So in this case, we're checking out our Roku, and that is 192.168.1.107. So we were correct on that. We saved it. Okay. So next, once done, save and close the file and navigate to the folder AWS Lambda inside the Alexa Roku master folder that you moved to your Raspberry Pi, and open it. And then right click on the server info.js and choose edit with notepad. Once open, change the IP address to the public one that you found in your router, DSL/cable modem, and change the 1234 beneath it to the port number you are using, in this case 40,000, and then save and close it. So again, navigating, we'll find our folder that we moved over, AWS files, and we'll go ahead and edit with Notepad. And I'll have to look up my IP address again and change it, and it has to be in between the quotes without any spaces. So at this point I'll have to blank out my IP address, even though mine's dynamically change every single time. Okay, we've saved that. And we've closed it. In the AWS files Lambda folder located in the Alexa-master folder that you copied your Raspberry Pi, right-click the index.js file and choose Edit with Notepad. Change the AP_IP to the app ID found at the developer website. Again, I'll provide a link to this below, but you should already have this bookmarked and know how to navigate through here. Next, you'll need to sign in to Alexa at the top, and then get started under the Alexa Skills Kit. You should see a skill you created, Alexa Roku, at the start. Once you click on the Alexa Roku, you'll be taken to a page where you'll find the application ID. You'll need to copy this ID and paste it into the index.js file. Again, you'll probably want to put a bookmark on your toolbar of your browser so it's easy to find it. Okay, so we navigate to our index.js. save the file. Okay, again, in the first line of the index.js file, next to the app_ID, you'll need to paste your application ID. Make sure to leave the quotation marks and also no spaces before or after the beginning of A and the last number of the ID. In that same AWS Files Lambda folder in the Raspberry Pi, right-click anywhere in the folder except on the files, and then click New from the menu and select Compressed Zipped Folder from the list. A new zip folder will appear. Now move all three of the files, indexinfo.js, index.js, and alexaskills.js into that new zip folder. This will only copy them into it and not actually move them there. So again, in a space anywhere except on top of the files, right click, select New, go down to Compressed Zip Folder. Now we've got that. We can open it up, see that there's nothing in there, and then we want to move all three of these in there. And we'll open it, make sure all three are in there. We see that all three are in there. Okay. So we've opened to verify that they're all inside. If all three, server.info.js, index.js, and alexaskill.js are in that newly created zip folder, we're ready to upload the folder to our AWS account. Now you can go to your AWS Amazon account, sign into the console. Once there, look for Lambda and then select Alexa Roku. You'll now be taken to the configuration page. Look under function. You will see code entry type. In the drop down list, choose upload a zip file and then click the upload button and navigate to the new zip folder we just created in the AWS files -lambda folder. Now click the save button at the top, not the save and test. So I left that website open. We will just select inline code, which is already there. Actually upload. Click the upload button. Find that folder we just created. And then hit the save button. If you have more than one Roku, unplug all but the one that you are setting this up for. So now would be the time to unplug all the other Rokus. Now open remote desktop connection and log into your Raspberry Pi. Once logged in, go to the terminal and type in npm install. Pretty sure you can just click the terminal button. But we'll open up a new terminal here. npm install. You should get a screen similar to this. And then we'll type in node space server.js. Looks like we might have typed something in incorrectly. Okay, it's throwing up an error here. Unexpected token. So this is going off of our server file, so evidently maybe we did something incorrect here, so we'll just double check it. Yes, here it is. We forgot it. We don't have our quote marks. That makes a big difference. We have to have our quote marks. We'll save the file again. Hit the up arrow key for our last command and enter. Okay, now this is what you should be getting. Server listening on port http://localhost 40,000. Okay, and node server.js. Okay, so now is the time to give it a test. Now I've renamed my wake word for this because I've also got this running on another Raspberry Pi in my home. Alexa, turn on Roku.
Okay.
So to test this, we're going to ask her just to go home. Alexa, tell Jacob to go home. And I don't know if you heard that or not, but it went home. So we are successful. That worked. So now that we know it works, we want to make sure that when this terminal closes, that it'll keep running the function. Even if the Roku reboots for whatever reason, either it crashes or power's removed to it and it has to reboot, restart, that we don't have to do this every single time, that it'll just automatically kick it in. And so how we would do that, see if we close this. Alexa, tell Roku to go home.
There was a problem with the requested skills response.
Because it was closed, we're going to get that error. So what we want to do is set up Node Forever. So we're going to install Node Forever. It must be installed globally. Copy the commands below and then enter them into your Raspberry Pi using PuTTY. So we'll open up our PuTTY. And we will get that first command. And while it's doing this thing, we'll copy the next one. We'll paste the next command in, press enter. Okay, so now using Windows Explorer, log into your Pi and click the folder home and navigate to the folder, etc., and open the file called rclocal with Notepad++. Now we need to change the file and add forever start /home/pi/server.js before the line, exit 0, and then save and close Notepad++. So we'll navigate, just click on home, go into a folder called etc., then go all the way down to the files, find that file that we need, which is rc local. right click on it, edit with notepad. There's our XC, so we'll need to copy forever start without the quotes. Oops. We'll go ahead and paste that in there, double check, make sure no quote marks, hit file, save, we can close it. Close that. Close our cancel there. Okay, if you're using Forever programmatically, you should install Forever Monitor. In this case, I'm just going to skip all this. Just stop node, just type in Forever stop server.js. If you made it this far and everything's still working, you're done. It's time to, again, fix a stiff drink and give yourself a pat on the back. So what I'm going to do is I'm going to give it a test. Alexa, tell Roku to go home. Oops, wrong one.
There was a problem with the requested skills response.
Alexa, tell Jacob to go home.
Going home.
Okay, so it's still working. Remember, if your ISP assigns a public IP address dynamically and your router reboots, you'll have to copy the new public IP address to the server info.js file and move that folder, that compressed zip folder that you created, and upload it to the AWS configuration page. This is why I recommend you plug your router /DSL/cable modem into a power backup. Buy yourself a power backup, plug it into there. That way, if your power goes out, you won't have to redo all this stuff. It'll just automatically work for your purposes. I'll go ahead and put the additional links down below so that you can read up and learn whatever you'd like to learn about this. Again, if you have any questions, just leave me a comment down below, and as soon as I read them, I'll respond to you, and I hope this helps you. Have a good day.